Okay, so I'm Eulers from Finland, an entrepreneur and free consultant in this BIM and scheduling scene. I'll just go quickly through my background so you'll know what kind of a guy I am and my experience. So once I started studying to be a Master of Science in Construction in Finland, I used the first summer times to work at the construction sites in pretty basic tasks like construction worker, quantity surveyor, and eventually foreman. The next step was on 2003 when my professor asked me in the school that, hey, tech student, are you in need of some pocket money? And obviously I was. So 2 weeks after that I was creating and controlling schedules in this huge Camppi Center project. Of course I didn't do it on my own because I just started. I had a good team to back me up, but I was the one doing the dirty work. So that's where I got in touch with Control Chart and the software that is now known as VICO Schedule Planner. Next step was in 2005 when Graphisoft bought the company where I was working, which made the scheduling software. And so BIM, we made the first BIM pilot in Finland for SRV in Espoo. But in that we were only responsible for, BIM side. The guys at SRV handled scheduling and production management. Then I graduated 2007. My master's thesis was about scheduling and special assignment, which is the next step down from master's thesis, was about BIM and utilizing it basically. After I graduated, I figured out that I don't want to be profiled as the technical guy who's clicking software, so to speak. So I went to real construction projects which are normal scale, normal size, and I was working there again in basic routine jobs as a site engineer and site manager and so on. So that took 5 years, and in 2012 I sort of came back to the roots in BIM and scheduling scene and was working in this project, which you might know. I was the guy responsible for scheduling and BIM at the site. So pretty much everything that's done in the site is my handwriting and my colleagues. And last summer I became an entrepreneur. And what I do today, the variety of stuff that I can do is there's a lot. And it all has to do with either BIM or scheduling or both. And when you combine these, it all boils down to information management. So that's, I think, where my work is going on now. And we also, with the guys in my close circle, we've tried to figure out new ways and find new equipment to be able to more efficiently benefit from BIM and to be able to collaborate and communicate with people. And so in short, I have a constructor's background, which is different from pretty much every other BIM consultant in Finland. They are either designers by background or software company people. So I actually know what living in the site is. And my tendency is to make things happen to the very end. Make sure that schedules that we do, they will actually be implemented, not just leave them floating and hoping that maybe somebody else takes care that they will be done. So that's for the background. And contents of my presentation is pretty much showing real-life examples of how to do scheduling and BIM. And I'll also be using the Tekla house that you saw just a moment ago in Sampo's presentation, because it's simple and easy, and it's easy to make the point quickly. So let's start by getting people acquainted to our construction site. Let's say a facade contractor, we're done the contract and the crew is coming to the site, and you should be able to communicate to them what the site is all about and where your work should be done and in which order. So you can either, well, use 2D drawings or just explain and point at the site, or you can use BIM to make it transparent and obvious that what we're building. So that was the building, this is our site, that's how it's arranged, and then show where areas for mobile cranes, tower cranes and storages are at the site. Using this, you don't even need to speak the same language. If you have, well, real looking objects there, these are just finished text and slabs, but if you have objects that look real, people can get the idea without even anyone telling them what it's all about. So on we go. So now that the facade contractors crew they know what our site is about, let's go through with the schedule. That actually is the top view of the building that we just saw, and then you divide it into different locations to be able to manage your work. And then based on that, it's pretty simple to make a flow line schedule where you have the different locations here and then the order of which you're doing them. And the production rate or the duration of the task varies because, well, the quantities in the facades vary as well. So that's the simple idea. Make the guys understand and explain, then it gets easy. So to the real life example, this is the Vallila site, and its facade schedule consisted of about 15 different facades. Let's see if I can get this working. So it's a lot more complicated, and the funny thing is that a lot of these facades are slanted. They are not straight, but they are leaning outwards from the building. So there you need special equipment to be able to work on the facade. So that's why, for example, here we have two. And then the schedule, how you should do it, there is no alternative or quick way around things. The mechanics, how you do it, is just the same, but of course the schedule will be more complex. And at this point, it really, how can you communicate this schedule to the guys who will actually do the work? Then the BIM model and the visualization of it, that it comes very beneficial. Makes things easy, and you can actually make sure that they understood the thing or the issues the way it's meant to be understood. Okay. Next, scheduling procedure in this big project. How we did it is, well, by the books, as I like to say, according to the theory and according to how you should be using that control software. So it all boils down to starting with that you have some quantity that's where your scheduled task is based on. Then you have some knowledge telling that how many men achieve how much in a day. For example, we in Finland have this Ratu data file system, which tells, for example, that, okay, plasterboard walls, you need 2 guys and they make 45 square meters per day. And that's how you get the duration. And the location is, well, most critical thing in production control. Because, well, only when you get one room done, let's say painted all the way, only then you can start installing carpets there, or otherwise you need to protect them somehow, and that again costs money and time. So one location at a time in a predefined sequence, and that's how it goes. So this is what we did ourselves first, because at the starting of the project we probably know like 2 of the contractors that will be working there. There will be 80 more, but the contracts will be made only a lot later. So we have to make the first guess of the schedule, even though I'm not an expert in electrical installations, for example. But still I need to figure out that what kind of tasks the electrical contractor needs and how long they should take, and then I need to figure out some quantity where the durations are based on. So that's how it's done first. And once we make the contract with the subcontractor, it's time to revise it. So that's what I thought. I think we need 2 men to get the thing done, and then the contractor says what's his opinion about it. For example, that they can only make half of it. But then it's pretty simple, because there we have the mathematics. Then it's easy to say that, well, then we'll just need 4 guys to do it, and we're back on schedule. And this is the discussion that needs to be done with every contractor, so that we both understand what's in the schedule, what it's based on, and if we understand it the same way, it's easier to make it happen. Okay. Back to the whole project itself. It's a banking block owned by OP-Pohjola banking group, and there are altogether 10 buildings, of which half were renovated and half were demolished away, and of course new buildings built in their site. And the main parts of the project were the new built houses on this side, and then the so-called gallery area. The whole inner yard was to be glazed with a glass roof all the way. And then third but not least, one simple building which had almost every wall were straight. That was given to a general contractor to do it sort of on their own. So that's the project, and the design tools used there are the pretty standard ones that we use in Finland. And we actually used these ArchiCAD and Tekla structures on the site as well for our own purposes, refining modeling at the site. So, how did we schedule everything? First of all, we started with, of course, the project schedule, which consisted of everything what's happening in the whole block from day 1 to deadline. And once we got closer, to the moment when there will be hundreds of people and a lot of tasks going on at the same time, we needed to split the schedule into smaller pieces. For example, the frameworks of the new built buildings, then the interior, which is, well, obviously the same as in the frameworks, but we combined these 2 locations here to make it, well, we did some calculations and figured out that it's more efficient to do it that way instead of doing A and B block individually. The gallery, we made our schedule for that, and the glass roofs as well, we split it into 5 different zones and managed it that way. and then again the facades, which you already saw. So that's pretty much how it's done. It's beneficial to, as long as possible, have everything in one single schedule, because it means one file. And one file with control means that you can manage all the dependencies between different parts of the project inside the one file. And after you split it into many subschedules, so these are separate files, and there still are dependencies between what's happening in the facade and what's happening in the glass roof construction, and those you need to do by hand, manually. So that's the split, and two reasons why to do it. Reducing the file size, the site is so huge that we had efficient computers and everything was okay, but still, being such a big building, there is so much data that it started to slow down in practical life. So that was one of the reasons to split it in smaller bits. The other one was that at that time I had my colleague with me, so we were two guys working on the scheduling and BIM. And once we had the schedule in one file only one of us could work on it at the same time. After splitting it, we could work on simultaneously. And also when it's in smaller portions, it's even for me easier to actually understand what's going on and how dependencies work. But the downside is that you have to manually, with eye-hand coordination, make sure that everything is in sync. Because when you redefine something in the frame schedule, it most certainly will affect pretty much every other schedule as well. Because if there's a delay, it will show in the other schedules as well. So there you have to be quite precise on to make sure that everything is synchronized. Then, scheduling is of no use if you make it for yourself. It only helps if you share it to the right people. The guys in the site are the ones who need to know what they need to do and when. And you need to control it rigorously. So first of all, you have to, of course, know the schedule, be able to communicate it to everyone applicable. And when you're controlling the schedule in a systematic way, you not only know exactly where you're at now, but you can also calculate, the software calculates for it, that if we continue working at this pace, where will it take us? If we're running late, what will it mean like next month? And so on. And it all boils down to leading people who actually make things happen. So, how did we handle schedule controlling? We had all the different schedules divided, and from those we printed out control charts for each and every contractor. Like the control chart is another way of putting the schedule. It has basically the same information as in flow line, but in a different manner for easy controlling. So basically, the contractor himself always knows that, okay, this is my schedule, and when they report it, they also already themselves know where they're at compared to the schedule. Instead, if you compare it to the, let's say, more traditional way, where every contractor has their own paper on which they report percentages, they often lose the sight about where we are compared to the schedule. So deal out the charts, and then the guys give it back the day before the site meeting, once a week, and that's how we formulate or form the big picture for the whole project. From small bits that are based on real information. And again, some bullets about controlling the schedule. Systematic procedure is the most important thing, and once a week is good thumb rule for any size project when to control it. Because if you update the control charts once a month, there's 3 weeks of time when you can, things start getting south, but you only figure that out after a month. If you do it once a week, you can only lose like 2-3 days of valuable time, and then you can start managing and controlling based on information. And also, you should know how to react on some troubles. Not all require at all attention, small things, but some others can escalate into bigger issues, and you need to know it. And you can find it out by, well, doing the controlling. Right, so that's scheduling part for now. So let's go through some Tekla examples. This probably overlaps a bit with what Sampo just showed, but well, these are real life examples. So let's start with the factory capacity. In our project we had a huge amount of steel frame. There were the actual buildings there, and then the whole glass roof sections were, well, let's just say that there were a lot of steel structures there. And we needed to figure out somehow that can we give the whole steel works to one contractor? I mean, can they manage it in time? And well, thinking about this afterwards, I guess there's really no other alternative to figure it out but to, well, in this case use Tekla. But what we did is we drove the schedule to the Tekla's scheduling tool, and then we're able to pull out a cool Excel, which was long. But from this Excel it was again pretty simple to devise a chart that tells us that this blue line here is the factory capacity. They promised that they can push out 50,000 tons, no, 50 tons of steel per week out of the factory. And then this other line here represents how much steel per week is needed at the site based on the schedule and of course the weight of the objects there. So it's obvious that there's a huge amount, too much needed, more than the capacity of the factory. But still, we made the decision that yeah, we'll take the one contractor and push design so that they can produce. I mean, use this downtime here to produce steel components well in advance. So there. Another issue is about updating the factory status. Let's go back a bit here. So in order to know if the factory is producing enough steel, well, we could use the Excel, which is long like hell, and it's pretty hard for the guy who's actually managing it, even for him to form a big picture about how we're doing. But if you highlight the stuff in the model, it becomes very simple and effective. I mean, anybody can, when they see the model, see that these are green and those ones are red, meaning that they are not done yet, and I know that I'm starting or should start erecting the frame next Monday, then, well, I can mention about it, because otherwise if it wasn't shown in the model, there was no way I could know basically what's the factory status. So the idea was such, and how we actually did it, how can we know what's going on in the factory. In this project there were 3 factories providing precast elements to the site. One was obviously the steel fabricator, and then there were 2, well, one concrete factory that was delivering precast wall elements, and then the third one was making the slabs. And this example here is from the steel fabricators reporting Excel. They used Excel for themselves already, so it was pretty easy task for us to take the Excel and modify it just a bit, so that we could, when we get the update, we only need to copy paste the stuff directly into Tekla. So that procedure took about 20 minutes per time, and we did it once a week if there were no other need to do it more often. So that's for the steel factory. The concrete wall element factory, they also used Excel to report, and the same drill we did there, so modified it a bit and then got it to the same track that it took the 20 minutes to update the status. And then last but not least, this Parma factory in Finland uses Tekla to drive their, well, slab making machines, so to speak. So they don't need drawings to make the slabs. They just need the model, and then they can drive their machinery to actually produce it, almost like just pressing a button. But well, and with them, since they were using Tekla, they could just push the information, status information, into the cloud, and then we could just at the construction site press one button, and it took a minute to get this kind of data up to date. So it took about an hour from my colleague Henry to do this routine every week, and when doing it, everybody in the site knew what's the status, because it's so obviously shown. And very simply, the idea is that these are footings, but anyway, the color coding issue is still the same. So basically anyone can see that, okay, the green ones are done, that's good. The yellow ones are under construction right now, and with the red ones we're running late, or we lack drawings or something. It becomes self-evident. Okay, then to combine these two, how to use BIM to visualize schedule issues to various people. We'll start off with the very early phase project schedule. So this was, the schedule is so coarse that it says only that this building framework will be done at that point and internal works after that. So it's very rough scale. For us in the construction site, this doesn't make much difference, but for the people working at the block, it makes the world of difference, because there were 2,000 banking people working at the site normally, and you can imagine what it's like when we are tearing down 5 buildings around them and then starting to construct. But no one of the banking people can understand what this is about, but this they can understand. So simple color coding, what's building and what's renovating and so on. And using this makes it again very evident Of course, this is just the raw video, but when you put months and dates there to progress, then it is actually usable. So that's large scale for normal people living there. And then for our purposes at the construction site, we also used similar kind of tactic. So this is a schedule of the demolishing phase and, well, the new build phase. And the trick here is that we tore down 4 buildings and then built 3 in their places. So obviously they don't fit into the old holes, so to speak. So that means that the location breakdown structure changes in between demolishing and new build. And even for me, actually, for others especially, but even for me, it was very beneficial to actually make this visualization very simply by just using Tekla BIM site and manually basically selecting what's visible and what's not. So month by month I could make it so that I even understood and was better able to communicate again what happens. The most important, interesting places were, well, of course, when you're demolishing a 10-story house, and then you should be starting already to build the one next to it. So, like, what happens? We need 20 meters of area there for protection during the demolition and so on, and also the interface between the structures that will remain there and what will be built new is, well, those were the interesting ones. And visualizing it this way made it easy. You can only imagine taking a look at floor plan views of the old building and then the new, and then try to compare and figure out what's happening. Okay, then the next phase, daily production management. We had the habit of having 2 schedule meetings in a week, on Tuesday morning 7 a.m. and Friday morning 7 a.m. 15-minute quick meeting with the key contractors. So we agreed on for the next 2 to 3 days. For example, if there's concrete pouring day, it means that the yard is pretty much jammed because there's not much room. So we need to synchronize what everybody's doing. And well, first we used just plain 2D drawings to mark up with the PDF to which part of the site is assigned to whom on which day. And when we got further, we figured out that the rock blasting isn't keeping up to schedule. We know it because we can monitor the blasting documents where well, it's an estimate, but it's still a very accurate estimate that how much will be blown with this blow up. And so we knew by square meters, that cubic meters, that we are falling behind the schedule with rock blasting, and we couldn't get any kind of answer from the contractor because we needed to know that, okay, we're falling behind. How much are we going to be behind when this is all done? And they couldn't answer. It was like just, well, let's see where it goes. But still, we had to manage the whole project schedule. For example, internal works. We had to start making contracts and be telling contractors that when will it happen. So to grasp some idea, we used our tech student who was on a summer job there. So we made him to simply model the rock surface just using sort of Lego block ideology. So every block is the shape and size of one blast. So that's how we could make some visualizations or guesses about how it could be done, and probably in time. So once we did that, we figured out as well that, okay, let's use it in, well, the daily planning, because it's a lot more visual than something else. So we took it a bit further and started to use the 3D view for easier communication. And once we started getting new construction done, also that status information was pretty easy to show people and plan ahead. Right. So this related to the rock blasting contractor. In the end, rock blasting cost us 3 months extra time, which was a lot because we had like 2 years to begin with. But anyways, so we figured out that how should we react to it? What's the correct amount of effort and time and resources to push something so we get back on track with the schedule? So we came up with the Pohjola's formula. It's shown pretty badly there, but the idea is that we need some amount of money to tell that what does a day cost in the construction site. So we took the project whole budget, then the average personnel cost per month for the construction management guys, which was about 40,000 euros, I think. And then divided by 2, so there's the arithmetic average, and then again divided with the rest of the days that we have left in the project. And there you get some value. And in Vallila, it was that, okay, one day costs 200,000 euros or 10,000 euros per hour. So it was a laugh at first, but gradually people started understanding that actually there is some idea behind this. So people started to shift from thinking that if, for example, I need to get a crane operator, let's say that the cranes are on my responsibility, which is a good thing to have because I have to manage and divide their usage to everybody. So I can't give them to some contractor only to be in charge, because I need to manage that. So I'm also paying for the wages of the operators. And now some concrete operator is running late, and to keep in schedule they should work on the Saturday as well. And they are willing to do it. For me it doesn't cost anything that they are working there on Saturday, but I need to pay the operator guy. Of course, the difference there is the bonus on Saturday, which in Finland is, let's say, something around 300 euros. So that's the extra cost that I should put, and by doing it, we are back on schedule. But the the way people react to this is that okay, it's on Saturday you pay 200% more wage, and then no way we're going to do it. Still, it's like 300 euros in cash. Or then they just compare it to what you have in your pocket and think like, okay, I have 40 euros, 300 is a lot more. No, won't invest that. But if you put it in this way, take it as an investment. Put the 300 in, get to 100,000 out. So don't compare it to what you have in your pocket. Okay, 5 minutes left. Okay. So yeah, let's talk about status information again. We went through it in a couple of places where, well, I told that, visualizing the stuff is pretty important and makes discussions simple. Using these, I'm talking about the same thing as the contractor or other subcontractor. If there's two guys talking about things without the model, it's very easy to actually be talking about two different things. This again makes it pretty easy and obvious. So that's important. And so this common understanding, how do you formulate it? That's pretty comprehensive, but if we go back to the old ways for a moment, and let's say that we are in the contractor meeting where everybody report their progress. And let's say that we are not using control charts. So basically every contractor has their own paper where they usually tell percentages. And one guy might say that, okay, we've done 50% and next 15 are under construction. Great. But the scheduling guy might be interested in the information that are we in schedule when we're performing this way. And then the usual answer tends to be like, and it's his fault because we're not in time. So, yeah. And no matter how you made your schedule, it's pretty easy to pull out percentages because it's just you have this line, even if you have Gantt chart, and then today is here, and it's about 75% to here. So you can tell that, okay, we're falling behind, and after this week we're like 10% off. You need to speed up. And then, of course, the contractor says that, yeah, we'll do it, or give it our best effort, without knowing actually what they need to accomplish, because making the 10% is a bit too abstract in the site. So trying to communicate this information to the crew who make it, well, good luck. Instead, if you use simple visualizations, it gets pretty easy. So the green ones are done, the yellow ones we're doing them now, and by Friday night we'll get it done. But the red ones are still the stuff that need to be done during the weekend in order to stay on schedule. And that's now communication becomes pretty easy. Talk to the guys themselves that, okay, you have like 5 footings and a couple beams. What do you need to make it on Saturday? Then they can actually answer and decide that, yeah, we'll do it. So that's common understanding. It really reduces waste when you're coming again tomorrow to look at the site and tell, hey, this isn't what we agreed on. And the other guy says that it is, or at least that's how I thought it should be. So using this eliminates a lot of that. Okay, so let's go to schedule visualization. It's again pretty simple to show comprehensively for, let's say, the concrete floor pouring crew, that's where they should be at, when, and in which order. So that's very simple. And now this is an example from my friends from Sweco. This is a hotel tower construction site in Tampere, Finland. And they took this pretty far. So the hotel is 27 stories or something. Well, I guess it's one of the tallest buildings in Finland. We don't have many tall buildings, but anyways. They didn't visualize the schedule with the model because they knew that they had 1 week per floor that they had to make it happen. So they actually, instead of using this to visualize the schedule, they actually figured out using the model that which bits and pieces needed to go in place so that we can get it done in a week. So that's, I think that's a very cool way to approach the problematics. All right. So next is pretty much about me and what I do nowadays. So the idea of utilizing BIM is a thing that, well, it will benefit cost-wise and well, it'll benefit you to adapt it. And well, for that, for example, you get consultancy from me or many other operators in the field. But the next actual big step is to be able to collaborate with people at the site. And for that you need new equipment. So for example, you can check out the website later, but we are doing work on figuring out that now that we're managing construction sites using BIM, what are the correct tools to be able to collaborate. That means getting the guys from the site to that kind of an office and be able to work on and brainstorm on the problematics that we have. So that's really when it starts to speed up, and that's a way to get the BIM all the way down to the field. Then in conclusion, again, you can do the BIM, but only if you share it, it becomes meaningful. So yes, you need to manage, but only when you are able to lead people, it actually produces something. So you need to take the knowledge all the way, otherwise you're just relying on luck. And that's about it.